Good afternoon, everyone, and welcome to my YouTube channel. So let's say we are looking at type 3 of showing that a number is an irrational number. Let's say we have the square root of 6 is irrational. Prove that the square root of 2 plus the square root of 3 plus the square root of 2 is also irrational. So how do you go about this? So the first thing is for you to assume that this number is a rational number. So you will first assume to say, suppose the square root of 3 plus the square root of 2 is rational. Meaning to say rational means it can be expressed in the form a over b, where a and b have no common factors, where a and b are members or have no common factors but are members of z. So z simply means integers. So a and b must be members of integers. Integers, we are just talking about positive and negative numbers. We are not including fractions. So now, and also the other condition is that b should not be equal to 0, because if b is equal to 0 and we replace where there is b, we put 0, a over 0 is undefined. So if that's the case, what we are going to have is our square root. Therefore, we can say square root of 2 plus the square root of our 3 should be equal to, we can have a over b, since you have attached this statement. Very important. So after attaching that, now we have been given that our square root of 6 is irrational. So we need to use this square root of 6 to prove. So how do we do that? So you know to say, if you multiply your 3 times 2, you are going to get 6. But you must ask yourself, how can I get 6? It is by squaring both sides. So squaring both sides means you are going to square this side, this side squared, even this side squared, like that. So what we are going to have is, we are going to have two brackets. So we have square root of 2 plus the square root of 3. Then we open another bracket, that's the meaning of squared, square root of 2 plus the square root of 3, which should be equal to, squared can be distributed, so we have a squared over b squared. Then our square root of 2, we are going to have the square root of 2, open brackets, square root of 2 plus the square root of 3. Then we have plus the square root of 3 times. So this first number multiplies everything. That was what I was doing. So square root of 2 multiplies everything. And this second number multiplies everything. So we have the square root of 2 plus the square root of 3. So this should be equal to a squared over our b squared, like that. So we are going to multiply. So we have the square root of 2 times the square root of 2. What this gives us is simply multiplying what is inside. So we have 2 times 2. It will be the square root of 2 times 2 is 4. Then the square root of 2 times the square root of 3 is what is inside, 2 times 3. So we are going to have plus the square root of 2 times 3 gives us 6. Then we have plus square root of 3 times square root of 2. It will give us the square root of 6. Then we have plus square root of 3 times the square root of 3. We are going to have the square root of 3 times 3. It will give us 9. Should be equal to a squared over our b squared, like that. So after doing that, here we have a 1, here we have a 1. So we can just add them normally. Square root of 4 gives us 2. Then we have plus our square root of 6 plus square root of 6. So as long as what is in the brackets is the same, you can just add what is outside. So we have 1 plus 1 to give us 2 square root of 6. Then we have plus our square root of 9 gives us 3, which should be equal to a squared over our b squared, like that. So after doing that, we can be able to say this will be this 2 square root of 6. Then this 2 plus 3, it will be plus 5. 2 plus 3 is 5 should be equal to a squared over our b squared. Taking the 5 the other side, we are going to have 2 square root of 6 should be equal to a squared over our b squared minus our 5, like that. So doing that will mean our 2 square root of 6 should be equal to, we are going to have our b is common here, so we have our b squared, then b squared divided by b squared is 1 times a squared, we are going to have a squared minus b squared divided by 1 is b squared times 5, it will be negative 5b squared, like that. So all we have to do now is to make sure that this is left alone. So how do we do that? So we can just choose to multiply by 1 over 2. So whatever you do on this side, you do it even on the other side, times 1 over 2. So this and this goes. So we are going to have our square root of 6 should be equal to this 1 over 2 multiplies with this b. So we are going to have a 1 times a squared, we are going to have a squared minus 5b squared, then over 2 times b squared, we are going to have 2b squared, like that. So if this is the case, we can now begin our contradiction. So remember, if you have we have said that where a and b are members of integers. So now the way it is, like let's say for example, if you have a minus 2b, so if your a and b are integers already, this will give you a, let's say a is equal to 1, your b is equal to 2. So we are going to just have, where there is a we put 1 minus our 2, where there is b we put 2. So this is just an example. So what this gives us is 1 minus 4, which is equal to negative 3. So now it doesn't matter the power. It doesn't matter the power as long as you have such a situation like this. This means that this will evaluate to an integer. So the integer, it will give you always an integer. So this also is also an integer. So integers are simply like numbers such as say, negative 1, 0, 1, 2. All these are integers. Integers do not include fractions. So now the way it is for rational numbers, as long as you have an integer over an integer in this case, then you will call that number as a rational number. Now that's a contradiction because we know, we have been taught that the square root of 6 is irrational. Now if we have integer over integer, we can say but the a squared which we found, a squared minus 5b squared over our 2b squared is a rational number. So if that's the case, if this is a rational number and this one is an irrational number, it means to say it is a contradiction. Contradiction because a rational cannot be equal to an irrational, cannot be equal to an irrational. So now, according to the question, we have been given that the square root of 6 is irrational. So that means that therefore our square root of 2 plus the square root of 3, since this is where we are getting the square root of 6 here, we squared this. So it also means that the square root of 2 plus the square root of 3 is also irrational. Thank you very much for watching. Hope you would like, subscribe and share for more so that my video may be pushed to a broader audience. See you in the next tutorial.